Well, hello and welcome to today's Enhanced Voice Services webinar. My name is Lance McCall, the Global Campaign Manager here at Ribbon Communications. I'm joined today by Prasanna Vijayakumar, Solutions Marketing Manager for Ribbon, as well as Harmeet Singh, Product Line Management from Ribbon. So happy to have both of them with us today. We'll get started in just a minute, but I wanted to point out the Ask a Question box at the bottom right of your screen. If you don't see that box, you can click the little question mark on the right side and it'll expand open and you'll see the Ask a Question box. We'd love to hear from you, so please ask your questions anytime during the webinar today. We also have a few documents for you to download, solution briefs, a couple data sheets, and a white paper. You can access those by clicking the document icon on the right side of your screen. So please do take those and take a look at that either during the webinar or afterwards. That's really all I have for now. I'll be back towards the end of the webinar to wrap things up. I'm going to go ahead and turn things over to Prasanna now, who will get us started. Prasanna, do we have you?
Yes, you do. Thank you, Lance. Hello, everyone. Once again, welcome to today's webinar on the VOLTE MRF and EVS Transcoding. We have some very interesting topics to share with you today, starting with some quick market updates and overview and information on EVS Transcoding, which is offering Ultra HD voice quality with RAN savings in your network, right? And why GPU-based transcoding? What are the business cases for enabling EVS in your network? And then similarly, what are the business cases to use GPU in your network? Also, some interesting performance details on GPU-based transcoding. We will share some details on the virtualized software-based transcoding at the core, and wrap this up with the deployment scenarios and information on our proof of concept POC program if you're interested in evaluating these, right? So let me start off with the current telecom landscape. Fundamentally, we all know that telecom landscape is changing, right? So in fact, the connected devices or the endpoint markets are growing rapidly. It's not just the devices market which is growing, but invariably the pressure it puts on your network when new services, it can be VoLTE and in future 5G services, which are going to be rolled out to your subscribers, right? So we definitely have more devices, more subscribers, and more real-time communication applications in the service provider's network at any given point of time, right? So obviously, with the growing number of users, the evolving network, the devices, there is a constant pressure, right, for operators such as yourself to innovate and offer new next generation services, with things to consider, for example, to reduce the customer churn, and of course, bringing in additional revenue, right, for per, ARPU, per additional revenue per user wise. So we all understand, your network is complex, considering we have so many different services offered, whether it is fixed TDM calls, mobile services, like 2G, 3G, or all the way to VoLTE services. There are millions of such subscribers who are still subscribed to these services within your network, right? And most of the operators here, are interworking between various services like over-the-top, unified communication, VoLTE, and all the way to your fixed line services, all either within your network or between different network providers, right? So obviously, with the current 5G initiative, VoLTE deployment, there is a case for operators more than ever to converge these different networks and experience and become flexible in offering or enabling new services, right, for the future. So what's common in these services offering? Like I pointed out earlier, there are so many of these services that you offer from your network directly to your subscribers, and most of the cases, you interwork all these services and also have challenges making sure you're interworking between different operators without compromising on the call quality, right? Irrespective of where or what endpoint the call is generated from, whether in the home network or a visiting network of an operator. We all know that the most common service here that ties all of these together is voice, correct? So subscribers want or expect clear voice as a default expectation, irrespective of the endpoints or devices they are using. Obviously, with 5G services introduction, the expectation of a clear, ultra high definition quality voice is definitely going to grow multifold, right? So as a service provider, we have a few pain points here that I would like to highlight. One is to offer a ultra HD quality voice service irrespective of the subscriber and their endpoints. And second is making sure there is a clean interworking and media pass-through without any limitation or things like call drops for your users. And last but not the least, a very robust transcoding solution that lets you provide a seamless voice experience to your customer, right? So why now? What's the importance of HD voice, right? Let's stop and take a look at this chart and understand the current VoLTE adoption rate and as well as the HD voice deployments across the world. So as per GSMA, we have about 158 operators who have launched VoLTE. This is as of October 2018 and in over 78 countries. So if you look at the LTE market, there are about 695 operators in 212 countries who have launched LTE services, and HD voice has been enabled in more than 164 operators across 88 countries, right? So given that the operators have invested a lot of time and money in their VoLTE networks and deployments, we all know services and handsets enabled with VoLTE infrastructure will be there for a very, very long time. So here I would like to, we'll talk more about this high definition voice and this market scenarios in the next couple of slides. But there are two surveys that GSMA conducted with their HD voice subscribers recently. One is showing more than 70% of the customers choosing HD voice as the loyalty factor, and the other one is saying that improved voice quality is greatly appreciated by most of these subscribers, right? So now let's try and understand the business case for transcoding in your network, right? So we all agree that your subscriber base evolves. They are used to experiencing next generation services, etc., from their over-the-top experience or similar real-time communication services from you. Now, as an operator, that puts pressure in our networks, right? Or as an organization overall, to give an improved user experience to your subscribers. Like from the survey above, majority of the subscribers look for a voice quality as a loyalty factor, right, to stick to their operator. And from service provider's point of view, you look at retaining your customers, right? So let's assume we all agree that improved user experience is one of use case for your transcoding. We also understand most of you here might already have a transcoding done in your network, right? Whether it is for mobile or fixed network, you might be already doing a variety of these transcoding in your network. So when we decide on delivering high quality voice through the network, we then look for how effectively can I implement a transcoding solution in my network, right? And what kind of CapEx or OpEx savings can I bring forward to my discussion, either when I'm implementing a new transcoding solution or going with upgrading the existing transcoding solution you might already have, right? So there are lots of use cases that will be considered when you start things like flexible deployments, whether you want to deploy a COTS hardware, whether you want to deploy on a public private cloud or an NFV environment, or stick to the appliance-based solution you have. So and then we will also consider things like there are other use cases, right? Whether can I reuse my existing transcoding solution in the network? Can it interwork and reuse my investment? So should I transcode at the core or at the edge? So end of the day, finally, the TCO, the total cost of ownership, and the return on investment will be based on the increased revenue, right, with any transcoding solutions that we pick. What kind of increased additional revenue per user I can gain by delivering this new Ultra HD voice services, right? That's another talking point there. Or now that I'm delivering these services with reduced network requirements, can I leverage or reuse these freed resources, right? and possibly apply these savings on introducing new products or services to these subscribers, right? Additional products or services. So invariably, when we decide on choosing a new transcoding solution or upgrading the existing transcoding solution, we have all these key business cases that we end up considering. So here we are, EVS Enhanced Voice Services Codec. It is an evolution of the existing AMR wideband codec, which is the high definition wideband codec for 3G, 4G mobile networks. We showed the adoption rate earlier. It's part of it, most of it. So EVS is the first 3GPP conversational codec that offers the super wideband and full band up to 20 kilohertz audio bandwidth, delivering speech quality up to a maximum hearing capability, right? So of course, this is a formal definition, for the EVS. So what it really means, this picture, which some of you might have seen from Qualcomm or similar vendor presentations, or our earlier presentations and webinars with regards to EVS, it explains the progression of different codecs, right, that are used in the wireless space, that is from AMR narrowband to AMR wideband to now EVS, right? So what it really means is EVS will deliver premium HD quality voice. It unlocks few different rates of operations. One is super wideband and another is the full band for users. And of course, these capabilities increases the sampling rate, right, wherein the voice is captured and it is delivered at better audio fidelity of what's being captured. So what are some of the commercial benefits of EVS, right, for operators? One is definitely improved network coverage and robustness. And what it means with EVS is that the choice of voice codec plays an important role, right, in assuring the quality of mobile voice service to your customers. So we understand operators have spent millions of dollars, on 4G LTE, VoLTE, small cells, and Wi-Fi network, to provide best coverage and capacity for your subscribers. While existing HD voice codec, which is with AMR wideband, promises to provide high quality service. Let's assume a bad network connection or low bandwidth access, which is predominant with this codec, can ruin the value proposition, right? So some of the primary benefits for the carrier is that EVS can deliver better audio quality with this new codec, and all with increased network capacity and efficiency. And from the end user perspective, it can deliver premium quality voice and better coverage with fewer drop calls. So another benefit, for the operator is that with EVS, based transcoding, you can support more subscribers, right, within the existing infrastructure. In simple terms, that is more calls, less bandwidth consumed. And last but not the least, for operators introducing EVS-based transcoding, it can help you save, bandwidth without losing the quality, right, that you're delivering to your subscribers. So let's look at this now. As an operator, you may ask, so why would I want EVS VOLTE transcoding in my network? Why can't I let the mobile phone users with EVS enabled handsets talk to each other, right, and avoid the transcoding solutions within the network? What we have shown here is that 20% to 80% ratio of calls inside service provider's network. That is, what we are talking about is 20% here is VoLTE to VoLTE calls, and 80% of calls being, for example, users with cell phone to another end user within your network, who might be a 2G or 3G user, or a voice over IP, or a unified communication endpoint user, or even users from different networks, right? And this call ratio, what you see at 20% and 80%, is from some of these discussions and surveys that we have done with service providers that we have already spoken with, right? So the key message here is that for the solution that is not having EVS transcoding and just waiting for the phone manufacturers to all support EVS, we are looking at this small subset of the total call volumes, right, that can benefit your users with high quality voice, and for you as a network provider, RAN savings. So, and there are, this 80% of the calls happening outside the EVS enabled handsets, and users are not able to experience the high quality voice within a network, right? As well as across the different service providers network too. Now, what do I really mean by different service providers network, right? So if, let's say, service operators decides to not transcode, and let's say that we let all the mobile phone manufacturers to enable EVS in their handset, which might take many years before all the phone users will have EVS support by default, and in the operator's network, let's assume that we just enable the media pass-through, then only those EVS supported handsets will get benefits of EVS, right, within just your network. And if an EVS enabled handset try and make calls to another user in another network or operator, you as an operator, unless you negotiate terms with the operator to let the EVS media pass through, your users will not gain that high quality audio benefit, right? So now with EVS transcoding in your network, we can not only enable 100% of the calls for your users with premium voice, but also enable a great amount of RAN savings for you within your VoLTE network, correct? So we spoke a lot about EVS and why EVS transcoding in your network. Let's go back to the market, right? Let's spend some time in this chart understanding the entire marketplace for, as you see here, we have mobile networks, we have VoLTE networks, we have LTE networks, and even now EVS enabled VoLTE networks, right? So there are approximately, according to GSMA and GSA organization, there are 700 plus mobile networks in the world, which is offering 2G, 3G, 4G, etc. All the mobile services. And what we know today is, LTE network as a basic data overlay is pretty much built out in most of these networks. So everywhere in the world we have LTE networks, and in some countries multiple LTE networks are available, right? That's what this report is showing. And in terms of VoLTE network launches, as of end of September 2018, as per the report, we have around 158 LTE networks who has launched VoLTE. And as you see, the trend is upwards, right? It's all increasing. The adoption is increasing, and of those 158 VoLTE networks, about 17 of them of the VoLTE operators have already launched EVS codec support in the network. That's quite significant, right? Because at one point of time, at end of I think around 2017, there were only a handful of VoLTE operators who has done that, and definitely there's an increase in adoption of those EVS launches. So what's interesting again is that it's not just the EVS adoption rate, but also that the VoLTE subscribers are growing, right? So obviously we are at 650 million VoLTE subscribers now, and most of you might already know that we are increasing or growing towards 3 billion, or some projects it to 5 billion users, right, in the next 5 or 6 or 7 years. So if you think what's the significance of this networks deploying EVS, is it just a cool niche technology to give your users? Well, what we know is of the 17 of those current EVS launches, those operators, if you add up all of the subscribers, it already adds up to roughly, I don't know, 15 to 20% of the global subscribers in the world. So we fully expect EVS transcoding being deployed as a mainstream codec in the VoLTE world. Well, now let's look at the EVS enabled handset manufacturers, right? As of 2017, we see an increased support from handset manufacturers who are EVS codec enabled. About, I think it's about 37, as per the report, it's about 37 different models from 11 leading manufacturers that support EVS enabled handsets. And we will be seeing increasing number of EVS supported handsets in the market, right? Which is another driving factor for EVS and VoLTE network and beyond. So these are some of the identified key business case drivers for transcoding with EVS. First, with EVS transcoding in your network, you can definitely give a better voice quality to your customers, which in return will retain your customers without moving to another network, obviously reduce customer churn, and also increases the confidence of being a subscriber in your network, right? With high quality calls, with fewer drop calls, etc. Of all the benefits of having EVS in your network, like we discussed a couple of slides earlier. And then we are talking about better RAN efficiency, right? Without going into technical details, with EVS, the technology is built with all these in mind, right? That is, if you have a voice user and a data user, for example, connected to your LTE tower, then most of the cases, I don't know, we have discussed that some operators that your voice usually takes priority over your data user, right? So with EVS, we can free up some of these, RAN usage, that is being used by your older cell phones or older codec-enabled phones. The network experience is definitely better, and not just voice. We can free up resources for your data users, right? With the same resource that you have. And last but not the least, there are EVS performance, tested and studies published comparing with AMR wideband in a channel-aware mode, right? Wherein it says that EVS has more gains, in terms of 2.5 dB, more gain with better voice quality and better network usage with increased capex saving for the operator, right? So what's important here is that from an operator's perspective, enabling EVS transcoding in the network is a good idea, which puts your RAN to better use, so that your users as well as you as an operator, have a quick return on investment, right, with spectrum savings if you decide to go with this EVS transcoding. And of course, as one of the is one of the key business case driver for EVS transcoding in your network. Now we spoke quite for some time on EVS transcoding. And Harmeet Singh now will share more information on the next biggest drivers with regards to transcoding. We have some good details on GPU-based transcoding that Harmeet will be sharing with you in terms of performance as well as EVS transcoding with GPU, right? Harmeet, would you want to take it forward from here?
Sure. Thank you, Prasanna. Good day, everyone. So today, as Prasanna outlined it for you, we'd be talking about how Ribbon is differentiating itself in the market on the transcoding front. But before we really go there, I'd like to begin by taking a snapshot of the communication networks today and review the same with you, right? So with transition to pure IP to IP network, IMS core adoption, and then adoption of COTS hardware-based virtualized software-defined networks, communication service providers have nearly championed their network infrastructure for future services. With the exception of specialized DSP functions in their network, which are still being delegated to purpose-built hardware-based solutions. And the prime reason for this has been that the CPU-based transcoding does not yet match the specialized DSP hardware-based transcoding solutions in terms of scale and efficiencies. And this is where we think the GPU acceleration is really the key. GPUs are being adopted across industry verticals for large compute-intensive functions such as image processing, machine learning, artificial intelligence. And the reason GPUs are being used in these domains is because GPUs are excellent at working with large data sets and applying similar processing on these data sets in parallel. And when you look at the large communication networks and their need to transcode very large number of sessions simultaneously, you would find the problem space warrants high performance computing clusters like a GPU. The other thing about GPU is that it's actually a COTS hardware and is generally available on nearly every popular public cloud platform like AWS, GCP, and Azure. Um, the GPU-based transcoding would allow communication service provider to finally complete their transformation to COTS hardware-based virtualized software-defined networks by moving transcoding off purpose-built hardware solution to GPU-based transcoding. Next, I would like to take you through data points on our transcoding solution, which should help you understand what do we mean when we talk about higher efficiencies or lower TCO per session for GPU-based transcoding. So what you have on this slide is that it essentially compares and demonstrates the GPU efficiencies that you are set to gain once you adopt it, right? Let's begin by reviewing the table at the top for EVS transcoding. If you look closely at this table, it lists out the number of COTS servers you would need for various deployment models. And the deployments model under consideration are only software-defined, virtualized deployment models. Those are the only options we are looking at. And if you see, we are giving you footprint estimation right from 500,000 session to 1.5 million sessions. And there are 3 deployment models. On the first row, you have 7+1 HS solution, which is pure CPU-based transcode. On the second row, you have 1+1 HS solution, which is GPU-based. And on the last row in this table, you have a very much like very similar HA model as the first row, which is 7+1 HA, but this row is for GPU-based 7+1 HA deployment model. So if you look at, I'd like to draw your attention to 1 million session deployment footprint. If you see, for 7+1 HA deployment with CPU, you would require 460 servers. That's a huge count of servers to buy and deploy. And then if we start off with GPU adoption, and then we go to the second row within this column, you will see with 1+1 HA, which is actually a better high availability model than 7+1, you come down to nearly 50% footprint. You require only 262 servers. And then if you want to be more aggressive, you go all the way to 7+1 HA so that we have a like for like comparison with GPU. The footprint becomes 1/3 in terms of server of what you really had with pure CPU based transcoding, right? So this smaller install footprint means you have fewer touch points in terms of installing, cabling, provisioning, or managing service, which means there are fewer manual errors and you can ensure quicker rollout of services, thereby making your network more nimble and agile to meet your business or market needs. Coming to rack space, assuming you're left with only 25 U rack space out of total 45 U in a rack, after putting in all the ancillaries for the rack, like likes of power strips or routers and stuff like that. For 1 million concurrent session capacity with CPU-based transcoding for EVS, you would require 20 racks. However, if you choose to adopt GPU acceleration for EVS, for same 1 million session, you just require 13 racks. That is 30% rack space saving right there for you. For AMR, if you were to do the same for AMR wideband, it would mean you would require 10 racks for CPU-based transcoding, and with GPU, it would come down to seven racks. That's again 30% rack space saving. Now let's look at we can talk about less power required, and that is somewhat evident by looking at the number of servers you need. But I would really like you to look at this slide here. What we really have is a bar graph which illustrates how many sessions for a given codec you can host for every watt of power. If you look at the G729 or G722, on CPU-based transcoding, you roughly get 12 sessions per watt, whereas on a GPU, that nearly triples to 35, 36 sessions per watt. That's nearly 66% more power efficient for these codecs the moment you transition to GPU-based transcoding. And if you scan through the table, in almost all the cases, minimum 50% power savings are guaranteed across all the codecs, with a highlight being EVRC, where you could see up to 80% of power savings. And let me point out, for codecs like G722 and G729, GPU is actually capable of delivering more capacity, but it's actually a CPU which is running out of breath and is not able to drive GPU further. So actually, for some of these codecs, CPU is the bottleneck, not the GPU. That should prove you the prowess of a GPU when it comes to audio transcoding. And if and we are talking about direct power savings here, right? For MRAP, and if you factor in indirect costs, say air conditioning, routers you would need, power rectifiers, UPS capacity for backup power, the savings magnify even more on the power front. Next, I'd like to take you through the business case for GPU-based transcoding. So with GPU acceleration, you would have a much leaner and agile network, which would not only be cheaper to set up in terms of hardware cost, installation setup, man hours, rack space in your colo, but would also be cheaper to operate in terms of power and management. And you would achieve this with 100% COTS hardware-based virtualized solution, which would contribute to your bottom line. For investment protection, from investment protection point of view, and once you invest in a GPU-based deployment, transcoding is not the only communication application that can leverage it, right? There are security applications like deep packet inspection, encryption, and then there are network analytic applications that going forward could leverage this infrastructure. So there is a lot of work happening on GPU within Ribbon, which for the communication space. So the investment or the bet you place on GPU is well protected in terms of the investment you make there. Moving on to next slide, Prasanna, if you can take me to the next slide, please. And just to reiterate, right? I mean, these are all the public cloud platforms where you can avail GPU services today. So GPU is no longer a niche and inaccessible technology anymore. You can today choose to have GPU-based solution on either private or a public cloud. Next slide, please. So, I promise this is the last slide, where we compare GPU versus CPU. Take a moment to read through it. I would like to sum up all the pros and cons that you see on this slide and leave you with a visualization I read somewhere. For a moment, consider CPU to be a sports car that takes you from point A to point B with a lot of zing, allows you along the way to take detours, would even allow you to take a few friends along for a fun ride. But then, if you have slightly more than few friends, say 300, are we visualizing a fleet of sports car now? Yes, it does sound very fun, but not very practical, isn't it? What if I told you there was another option, say a maglev train, which is faster, more comfortable, and very efficient in taking people from point A to point B? However, this maglev train only would make sense when there are enough passengers. I'm sure you guessed it by now, this maglev train is GPU. Next slide. So on this slide, we are essentially outlining for you that Ribbon offers wide range of deployment models for our transcoding solutions. We have solutions that align with various network transformation stages or strategies. We can provide virtualized solution for on COTS hardware for both CPU and GPU, or we can provide CPU and GPU based transcoding for both private and public cloud. We can provide appliance experience also, if that's what makes more sense for you. And finally, you can always go the hybrid route. Say you choose to host a transcoding in a private cloud, but then you also service a remote geography for a few important customers, but then you don't really want to host your own cloud in that region for business reasons or other reasons. It could be regulatory reasons. For this remote location, you can choose, in this scenario, you can choose to host your solution on a public cloud or a COTS hardware-based virtual solution or even an appliance in this remote location. And this application would integrate seamlessly with our private cloud that you would have chosen to host in your main market. So that's the wide spectrum we offer in terms of deployment models. So at Ribbon, so this slide sort of again gives you a snapshot of how networks look today, right? You have an IMS core in the center, and then you have a 3G network which would slowly get phased out, and then you have 4G VoLTE mobile, which are upcoming networks in some of the regions. And as you can see, right, I mean, there's a EVS codec listed there. And then on the other side, you have fixed, enterprise, fixed, and IPX networks, and you have upcoming cloud UC. So you see, I mean, it's an ever transitioning model, and which is the prime reason industry has chosen to transition towards IMS core based architecture, because it sort of made the whole network access agnostic, right? You could deploy services on IMS core, and those services could be rolled out irrespective of what access network you're interoperating with or choosing to roll out. So at Ribbon, sorry, Prasanna, can you go back to the previous slide? So at Ribbon, we've been offering transcoding solution to service providers for more than 19 years, and we've been playing on both sides of the code, be it transcoding at the edge via our SBC portfolio, or transcoding in the core with our MRFC, MRFP solution. All these years, one thing has been very clear to us, that transcoding is inevitable due to market dynamics. You can optimize your network to reduce your transcoding need, but then market forces will always surprise you. And so having a comprehensive transcoding strategy is unavoidable for communication service providers. Next slide, please. So this slide, we would like to highlight why, there are pros and cons of all approach, and we just wanted to emphasize how a centralized transcoding at core can pay higher dividends over a longer period of time. Having centralized transcoding at the core allows communication service providers to leverage their transcode capacity across multiple networks that are tied to the IMS core, pretty much along the IMS architecture. It enables them to roll out services across various networks centrally much faster, again, contributing to their top line, right? It allows them to pick best of breed transcode technology, given the IMS core is vendor agnostic. So you're not tied to a single vendor solution or its roadmap. The whole world is an open playing field. Based on the transcoding technology evolution, you pick the best of breed and slot that into your network, because your network has a centralized transcoding and is standards based. Now I'd like to hand over back to my friend Prasanna here, who take us through some of the solutions that Ribbon offers in this space and talk more about it.
Thank you, Hermeet, and welcome back. So now with Ribbon, we have an amazing end-to-end portfolio of transcoding solutions, right? So whether it's for carriers transcoding need, whether at the core or the edge or a combination of both, in hybrid deployments, we have an amazing set of products that are proven and carrier grade, right? And that can enable most of the business cases in terms of transcoding that you saw earlier. So saying that, we do have an EVS enabled MRF transcoding solutions. We have whether it's MRFP, whether it's in a COTS based or appliance based or virtualized, we have the solutions that are ready to be deployable in your network, right, with EVS support. So some of the operators here already might have some of the Ribbon's transcoding solutions in your network. And obviously we offer complete investment protection to you in terms of interworking and then deployment scenarios, and making sure enabling all these above benefits, right, while you evolve your network with the new virtualized software only transcoding solutions, right? So before I talk about the proof of concept program, I would like to summarize saying that we have a extensive experience of being a standalone MRF transcoding vendor, right? And we have extensive experience of working with leading tier 1 operators across the world. We have supporting almost 200+ million VoLTE subscribers, and we are constantly evolving our portfolio too, right, and enabling new technology for our customers like you, and also to differentiate ourselves as a solutions vendor for partner for you. So what I've done is I've highlighted a few of the key differentiators to wrap this up, which is GPU based transcoding. Hermeet gave performance details, evaluation, etc. And second is the the intelligent media node selection feature, wherein the Ribbon MRFC has the capability to optimally select the best media edge network functions or the appropriate MRFP nodes, which are closest to the subscriber, right, in your network. So this is very valuable in terms of certain MNOs to assure best media optimization and service quality in a long run, of course, and as an investment protection, right, if you have some of our MRFP nodes in your network. So the third is, of course, the fully virtualized transcoding. We spoke about this earlier in our slides again on why software-based MRF transcoding, and of course the flexible deployments. So we give the customers to pick from software-based or appliance-based, or let them deploy hybrid scenarios, whether they want a GPU or a CPU-based transcoding or a combination of both. We can provide many options, right? And the last is the patented media processing. What it means is no dependency on third-party, the DSP vendors or codec implementations, which again gives us minimal licensing burden and more control on further optimization of our software that we are putting in your network, right? With this, before we wrap this up, we would like to find out from the audience here for follow-up discussions on some of these business cases, right, with GPU or EVS transcoding, or you want us to work with you for a proof of concept to test our solutions or product in your network. You can either contact our accounts team directly, or we can also ask our experts to get in touch with you. So please let us know in this window, in the next window that Lance will put up, whether you're interested in a POC or you want us to work with you to draw out a business case for these transcoding scenarios that we have started with you, that we have shared with you earlier in our presentation, right? So Lance, please go ahead and bring up the form. In the meantime, while you're filling in your request, I think Lance will ask questions, or you want to talk about this question poll that you put up?
Yeah. Thanks, Prasanna. Hopefully you guys are seeing the little poll question that's up on your screen right now. As Prasanna mentioned, just confirming your interest in either some help choosing the right solution, or perhaps you're interested in one of the proof of concept programs, like for the AWS or the GPU. So make your selections there. We'll close that poll here in just a minute. But yeah, looking at some of the questions that have come in, and first of all, thank everyone for their participation. We have a couple that we can address real quick. So Prasanna and Harmeet, are there any special features that are available with a centralized transcoding solution? That's the first question.
So that's a great question, right? So I think that's what I was addressing a little bit earlier on the investment protection wise. From Ribbon's perspective, we have this feature called intelligent media node selection feature. As I was telling you, the appropriate that is the Ribbon MRFC, or has the capability to optimally select the best media edge network function, or the appropriate MRFP node that are closest to the subscribers, right? Again, this is a very good value add, and also it shows us that how we can reuse the existing investment that you might already have with your MRFPs deployed in your network, right, or media gateways in your network.
Okay, good. And I think, by the way, I think we've got everybody answered the poll, so I'm going to go ahead and close that poll out, and we should just still be seeing your last screen there, Prasanna. Another question that came through is, does this Ribbon solution work with any third-party MRFC?
Let me take that, Prasanna. No, today our MRFP solution does not work with third-party MRFC, but we'd be, talk to us, let us know what your requirements are, and we can figure out a way, that works best for you. We'd be interested in strategic partnerships as and where it is needed.
Okay. I have one last question here that came through. Can I choose to deploy a CPU-based transcoding solution and migrate to a GPU-based transcoding solution using the same COTS hardware?
Okay, well, that's a very good question, and I'm glad somebody actually asked it. So the answer is actually yes and no. So the thing is, today the GPUs, the enterprise grade Tesla V100 or the later GPUs have a specific requirement on the hardware where they're deployed. And for that, if that's where you want to go, you want to start off with the COTS hardware-based, CPU-based transcoding, and then go to GPU-based transcoding, then we would need to select a COTS hardware which is GPU compatible. And then, we can have you get started with CPU-based transcoding. And then, of course, you can transition to GPU-based transcoding. It's just that we need to be careful what COTS hardware we pick there. That's the only consideration. The other thing about the GPU is you need a 2U servers, given the GPU blade size, and it has some certain power and cooling requirements. So we have to work through all those considerations to help you pick a COTS hardware for this. But this is certainly possible.
Okay. Well, that's really all the questions we had, Prasanna, Harmeet. Prasanna, I guess I'll just throw it back to you to mention the downloads that we have here.
Yeah, there's so we have a good set of content for you to to download and read through in your free time, and obviously Lance will be sending out information on this replay of these of this webinar. Feel free to let us know. We have got your interest on POCs. And that's great, and we will definitely reach out to you for the next plan of action on those for those who have requested for it. And saying that, I think we have 10 minutes to go, but if I don't see any further questions, and I pass it back to Lance. Thank you once again for everyone to attend this webinar. And
Yep. Thanks, everyone. Do appreciate the time. Thanks, Harmeet. Thanks, Prasanna, for the presentation. While I'm speaking here, you can still access all these documents on the right side of your screen. There's a little document icon. Just click that. You should see all these downloads right there for you to take. As Prasanna mentioned, you will get an email this afternoon with a link to the replay. If you'd like to have the slides, just reply back. We'll get you those slides, no problem. Also, you can find all this information and much more on ribboncommunications.com. If there's a question that comes up that you didn't get answered today, feel free to fill out any contact form on the website, and we'll make sure that gets in the right hands. Those of you who did select that you're interested in the proof of concept program, or that you need more help, just selecting the correct transcoding solution, we will be in touch with you shortly. So we do appreciate everyone's time. Thank you so much, and enjoy the rest of your week.